Let's dive into what is probably the single most important skill for anyone working with AI right now: prompt engineering. Seriously, it's the difference between just asking a question and getting a pretty good answer versus actually telling the AI exactly what you want and getting something incredible. It's not just about typing, it's about learning to speak the language of these new machines to unlock what they can really do.
Arthur C. Clarke really nailed it with this one. Because when you're interacting with a powerful large language model, or an LLM, that feeling is totally undeniable. It just feels like magic.
We've all been there, right? You type a question into a chat box, and bam, in seconds, you get back this coherent, detailed, and sometimes shockingly creative response. It really does feel like you're talking to something that actually gets you.
But here's the thing, it's not magic. And for this explainer, we're going to pull back the curtain and see exactly how the trick works. Because once you understand the mechanics, that's when you go from being a casual user to someone who can truly harness this technology.
So, let's start with the absolute fundamentals. What is a large language model actually doing under the hood when it seems like it's thinking?
No matter how deep or complex the conversation feels, at its very core, an LLM is a next word prediction engine. That's it. It's been trained on a mind-boggling amount of text, and its one and only job is to calculate the most statistically likely word to come next, and then the next one and the one after that. This surprisingly simple foundation is what builds those incredible results. And our side of this conversation? Well, that's the prompt. It's the instruction, the question, the chunk of text that we feed the model to get it started. This is our main tool for steering the ship.
And even a simple prompt like this is incredibly powerful. You can specify a tone, who it should sound like, a few key tasks to include, and boom, you get a perfectly crafted email. Just think of the hours something like that can save. But trust me, this is just scratching the surface. We can go so much deeper.
All right, now for the first huge leap in prompt engineering, getting a handle on the idea that context is king. I kind of like to think of this as the Little Red Riding Hood principle. Your prompt, well, that defines the path to Grandma's house. But the context, that's the basket of goodies that keeps the model focused on the goal so it doesn't wander off the path to talk to wolves.
So why is context so incredibly powerful? It's because the model's entire universe is just the text it was trained on. So here's the secret. To get the kind of output you want, you have to make your prompt look like something the model has seen before. You've got to speak its language.
This chart gives you a little peek into the model's diet. It has consumed academic papers, huge swaths of the internet, countless books, and millions upon millions of lines of computer code. And that's why you can ask it to write a formal report 1 minute and a Python script the next. It's just completing a pattern that it already knows inside and out.
And this just shows you the power of context perfectly. On the left, you ask for a book recommendation and you get a generic classic. Fine. But on the right, you add a few personal details, your age, your interests, maybe where you traveled recently, and suddenly the recommendations become incredibly specific and relevant. You're just giving the model more clues to find a much better pattern to complete.
Now, we can think about context in two main ways. Static context is like the permanent mission briefing you give the AI, the core rules of the game. But dynamic context, this is where it gets really powerful. This technique, often called RAG, lets the AI pull in fresh, real-time information, like today's news headlines or your company's latest sales data, to answer a very specific question.
Okay, so we've given the model some guardrails with context, but what about getting it to actually think its way through a problem? That's the next level up.
Here's the weird part. LLMs don't have an internal thought process like we do. They just generate the next word, and the next. So if you ask them a complex logic puzzle, they might just jump to the most statistically likely answer, which a lot of the time is just plain wrong. So how do we get around that?
The solution is actually kind of amazing and surprisingly simple. We basically force it to have an internal monologue, but on the outside. By adding one simple phrase, "Let's think step by step," we make the model write out its reasoning before it gives the final answer. Each logical step it writes down becomes new context for the next step, guiding it toward the right conclusion. It's a tiny trick with absolutely huge results.
Now for the really futuristic stuff. We've given the AI context and a way to reason. What if we could give it the ability to actually do things? This is where prompting starts to look a whole lot like programming. This is done using what's called a tool loop, which you can see mapped out here. We basically describe external tools to the model right there in the prompt. Things like a calendar API or a search engine.
The model can then decide in the middle of its process to call one of these tools to get new information or even perform an action in the real world.
The React framework is a fantastic example of this in action. It's a simple, really powerful cycle. First, the model thinks about what it needs to do. Then, it takes an action by calling a tool. And finally, it makes an observation based on what the tool gave back, and it folds that new information into its next thought.
So, we've gone and built this incredibly sophisticated tool-using reasoning prompt. But that brings us to the final and maybe most critical piece of the puzzle. How do we actually know if it's any good?
You can't just kind of eyeball it and say, yeah, that feels better. To improve something systematically, you have to be able to measure it. And this is what really turns prompt crafting from an art into a repeatable science.
The whole goal here is to move past feeling like a prompt is an improvement and start proving it with cold, hard data. We need objective metrics that can tell us without a doubt if our changes are actually making the AI's output better in a measurable way.
And there are a ton of ways to do this. For instance, some metrics measure text similarity. Think of it like a game of spot the difference between the AI's answer and a perfect, gold standard answer you wrote yourself. Others, and this is a fascinating twist, will actually use a second LLM to act as an impartial judge, scoring the first one on things like fluency, relevance, or accuracy.
So when you put it all together, you can really see the whole journey of prompt engineering. You start with a simple instruction. Then you add context to guide the model. You get it to reason to improve accuracy. You give it tools so it can take action, and then you evaluate everything so you can refine and improve over and over again. Each step just builds on the last. Which leaves us with a final thought to chew on. This whole process, this art and science of prompt engineering, is really about learning to speak the native language of AI. So as we get more and more fluent, are we just becoming more clever programmers who use words instead of code? Or are we, step by step, actually teaching these machines what it truly means to understand?